Hello, everyone, and welcome to your science review lesson on matter with your favorite 4-H agent, Jonette. So, welcome. Before you all left school, you should have received a Ziploc bag that had a little kit inside. You will need that at the end of this lesson, so please make sure you have that handy. So now, let's begin our lesson. Matter matters. A matter of fact, matter is anything that has mass and takes up space. And that also means it has volume. So no matter what item you pick up, it has mass, okay? And it is made up of matter. So if you have an ink pen nearby, that is matter. And it has a mass, which means it takes up space, okay? It has volume. Mass is the amount of matter in an object. So that is a measurement of how much matter it took to create that ink pen. Even if you look at water or your Kool-Aid or your juice, that has volume. It takes up space. So even when you think about that glass of water, and we're saying mass is the amount of matter in an object, the mass of water, what is it? How much matter did it take to create water? And we'll get to that later. Matter does not gain or lose mass during phase changes. It does not gain or lose mass. It may change from one phase to another, but the same amount of stuff that it took to make up that object is always going to be there in one form or another. And that's what it means when it says phase changes. So, you know, water goes through multiple different phases. It can be a solid, it can be a liquid, or it can be a gas. But no matter what, if you take one ice cube and melt it, you still have the exact same mass. If you change it into water vapor, which is its gas form, it's still going to be the same amount of water that it was in that ice cube. And if you condense it in the air and contain it, you will still have the same amount of water as you had in that ice cube. Matter can be broken down into the tiniest particles called atoms. Atoms cannot be seen with the naked eye. And you may remember that from before. Atoms are the smallest particles. They are the smallest building blocks, okay, that makes up matter. So if you want to know what kind of matter is in water, well, then you have to look at its atomic structure. Matter takes up space, and everything has mass and takes up space. Even air has mass. So then what is in this jar? And here you notice that we've got this jar of jelly beans, okay? And the jar is full of jelly beans. But my question is the jar full? And I want you to look closely and tell me, is the jar full? This jar is full of jelly beans. But there's something else in the jar with the jelly beans. Air. Air is also in the jar with the jelly beans. So if the jar is full, it is full of air and jelly beans. Now the jar, as you see, is full of marshmallows. So then my question to you is the jar full? Okay, let's see if we can fit anything else to our jar with marshmallows. Here I have sand. I guess the jar wasn't full because I can pour sand into the jar.
Okay, so now we have poured a bunch of sand into the jar on top of the marshmallows. So then my question is the jar full? Sand is all around the marshmallows. Being careful not to spill it out. Is the jar full? Matter takes up space. If there is space to be had, matter will fill it up. Matter has different particle sizes. Marshmallows are large, sand is small. But is the jar full? Let's find out. I've got some water. Let's pour water into the jar. The water is moving down. It's taking a minute to soak through the sand. Look, I'm still able to pour a little bit more water in. I fear it's going to take it a minute to soak all the way down through the jar. But what you can begin to see is that the water is penetrating and permeating through the sand, and eventually it's going to reach the bottom of the jar. As you can see, you've got the top of the jar here and the water soaking down through the jar. And you can see the marshmallows are soaking up the water, which is able to displace some of the sand because now the sand is no longer at the top of the jar. So all that space in between the jar has been filled up between sand and water and marshmallows. But when we thought the jar was full of marshmallows, the jar wasn't full because we were able to add sand. And after we added sand and filled in all the little holes, we were still able to add water.
So let's talk about mixtures. What are they? A mixture is what happens sometimes when two or more substances are combined. They do not lose their identifying characteristics. These substances are called mixtures. And examples of mixtures include soil, concrete, even a mud puddle, because it is a mixture of water and soil. A solution is a type of mixture, and solutions are a special type of mixture in which one substance is uniformly dissolved in a liquid. So think about salt and water. Think about food coloring in water and sugar in water, especially when the sugar actually dissolves in the water. But then you also have suspensions. Suspensions are another type of mixture, okay? And this is a special type of mixture in which one substance does not dissolve in a liquid. These are bigger particles of things, and they easily settle out of the liquid upon standing still. So think about sand and water. You can mix up sand and water together, but if you let it sit, eventually that sand will settle to the bottom of the glass. Oil and water is another example of a suspension because when you mix it up, the oil is suspended in the water. But when you let it sit still, the oil will stay on top of the water. The suspension, called a colloid, has solid particles that are suspended evenly all throughout a liquid. The solid particles are smaller than those of a suspension, but it's larger than the type of particles you would find in a solution. So colloids can be made up of a gas-liquid combination, like whipped cream, a liquid-liquid combination, like mayonnaise, a solid-liquid combination, like Jell-O, or a solid and a gas, like air. Yes, I know that sounds strange when you think of a solid and a gas, and then I say air. But do this. Go into a dark room, turn on a flashlight, and in the beam of light, you'll see tiny little particles floating around in the air. So when those solid particles like tissue and dust are hanging around in that gas floating around in the air, it's actually called a colloid. It is a solid gas suspension called a colloid. So let's think about the big concept here. Everything is made of matter, and thus everything is made up of atoms. That is the smallest particle of matter, of everything that makes up everything. So as the mixtures combine together, which we just talked about those mixtures, as those mixtures combine, sometimes they make new bonds, which give them different properties. And that's how we create all these new things that you see. So let's talk about atoms, the different types of atoms and what they are. Okay, atomic structure, what's it all made of? So here we have the periodic table of the elements. Now, what I want you to think of this periodic table of elements as a kitchen where your mom creates things and makes things, okay? Everything that exists in the world is found on this periodic table of the elements. Everything. Nothing exists that does exist if it doesn't have one of these ingredients in it, okay? So if you look at the periodic table of elements as like a chemistry set or like a cooking set, you need to make dinner. Well, what are you going to make? I don't know. What are we going to drink? Well, let's have a glass of water. So water is made up of a hydrogen gas atom and an oxygen gas atom. Matter of fact, we know water as H2O. That means 2 hydrogen atoms and 1 oxygen atom. And now we're going to mix them together, combine them. And when we mix hydrogen and oxygen together, those atoms bond together, meaning they share electrons. When they do that, those gases become liquid, water. So when we break matter down into its smallest part, we're talking about atoms. So now let's take a look at some atoms. So hydrogen atoms is an atom of the chemical element hydrogen. Its parts are a single negatively charged electron that circles a single positively charged nucleus, which is here, that's our nucleus, of the hydrogen atom. The electron is bound to the nucleus by the Coulomb force. So our proton in the center is 1. So we have 1 proton and 1 electron. Now, our nucleus is made up of neutrons and protons. Our neutrons have no charge. They are neutral. A proton has a positive charge, and an electron has a negative charge, okay? Negative and positive attracts. So this positive proton is keeping this negative electron hanging out in this electron cloud that is all around this center nucleus. So now let's look at an oxygen atom. An oxygen atom has 8 protons and 8 neutrons in its nucleus, okay? So this round ball right here makes up the nucleus, which is comprised of 8 protons and 8 neutrons. In the electron cloud circling around, all around that nucleus, you also have 8 electrons that are holding on and staying close to the nucleus. So then when we create water, we're creating a molecule of water. So 1 water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. And as you notice, These electrons overlap in the electron cloud of the hydrogen atoms and the oxygen atoms. And yes, it does look like Mickey Mouse. So a group of atoms that are stuck together represent the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. So when you have a glass of water, you have a bunch of water molecules together in that glass. So now water is a molecule, and when it's a liquid molecule, many things can dissolve in it. So let's take a look at a sugar cube and how it disintegrates. So when you take a sugar cube, you've got sugar packed together that makes a square, right? But we know that there are tiny little grains of sugar that would make up a sugar cube, right? So these tiny sugar cubes get put into water. And you know, if water is cold, then you're going to have a hard time having the sugar to dissolve in the water. And so after all of the sugar is dissolved, then you end up with a sugary solution, which means that the sugar has dissolved evenly throughout the water liquid material, creating a solution. So then what is going to dissolve these substances better? Hot water or cold water? Would small particles be easier to dissolve in water than large particles? So let's experiment. Let's play a little game of dissolve it or not.
Time to play dissolve it or not. And that whistle means the water is hot. To get started, we're first going to use our Swiss Miss hot chocolate. We'll see how much of that starts to collect at the bottom of our jar by the time we get to the end of our experiment. So to begin with, will it dissolve or not? I'm going to add 1 cup of hot water to this clear mug, and I've measured out 2 tablespoons of sugar in these little dishes. In this mug here, I'm going to put regular room temperature tepid water from the sink. First is add the 2 tablespoons of sugar into the glasses. And in this glass, I'm going to put the 1 cup of room temperature water. And you can see the sugar settling through the water as that water clears to the bottom. I'll measure out 1 cup of our hot water and pour that into our mug. So which one dissolves better? Hot water or the cold room temperature water? If you said hot water, you are correct. One more dissolve it or not experiment. This time we're going to use baking soda. I've measured 2 tablespoons of baking soda for each one of our glasses. Once again, we're going to put that water straight out of the faucet there. And then I'm going to measure out 1 cup of our hot boiling water from our tea kettle into our mug. And let's see if baking soda dissolves in water. Here, there's no baking soda. We're at 55 seconds. Let's take a look at our other one. We've got chunks of baking soda still at the bottom. The hot water obviously dissolved more of that 2 tablespoons of baking soda than our 60-degree room temperature water. Bring forth our hot chocolate. What do we see settling at the bottom of our Swiss Miss hot chocolate? I do believe that's chocolate. Some is still being suspended. Some particles are still being suspended in the air. But look at our spoon. We can see those particles even settling out when we put our spoon in there. So let's mix. And you can see how once again it's being mixed back into the water, which makes hot chocolate a suspension, a solid being suspended in a liquid. Hot water dissolves things better, but why? Hot water has more energy. When water is heated up, the molecules gain energy. They get hot and they want to separate, right? But that means they start moving faster in that pot. They have more energy because as that hot water moves into it, it's going to keep bumping into it, take a little bit of it, take a little bit of it with it until it's completely carried all throughout, evenly dispersed in the water. So now let's talk about the fan favorite concoction, slime. Let's get slimy. You're going to need your slime kit for this, and that is in a Ziploc bag that you received before you left school. But let's first think, what is slime? Is slime a mixture? Is it a solid? Is it a liquid? Or is it a gas? Is it a suspension, a solution, a colloid? And if it is a colloid, is it a gas liquid, liquid, solid gas, or solid liquid kind of a colloid? To make our slime, we're first going to add the glue into our bowl, our parent-approved slime making bowl. Add as much glitter to your glue as you would desire. You don't have to add glitter if you don't want. Mix it in, and then add your baking soda to your glue. And you're going to mix your baking soda with the glue and the glitter together. Make sure there are no chunks of baking soda in your glue. Next, you are going to measure a little bit, about half of your contact solution into your glue mixture. Your contact solution is an activator that will begin to make your slime glob up. Stir until you notice that it's not doing any good because it's starting to glob up. At that point, you're going to need to use your hands. So knead your slime with your hands. It will be very, very sticky, but keep working it, keep kneading it, and you'll realize and notice that it'll get less sticky. Once you've worked it for a little while and you realize it's not getting any less sticky, add the remaining amount of contact solution to your slime. You may also need to add a little bit more baking soda if you have some on hand. Keep kneading your slime until you notice it is the consistency that you prefer. Enjoy your slime. Thanks for tuning in. And if you want more fun science things, stay tuned to our Facebook page. Here's our Facebook address right here, www.facebook.com/ccva4h. Or you can email me. If you have any questions and want to do more fun sciencey things, then call me. And you can also go to our website located right here and find some other activities that you can do at home that will keep you interested and engaged in science. I hope you enjoyed your lesson and I hope you enjoy your slime. So please, please, please use your slime responsibly and don't put it on fabrics or clothing. Okay, keep it in your Ziploc bag so that way it doesn't dry out and turn hard. All right, so I hope you all enjoyed your lesson. If you have any questions, please contact me or contact your teacher. Either way, I will see you in the new year. Merry Christmas. Happy New Year.